Okay, we're gonna pick it right up where we left off. You guys can figure out how I'm doing this right now, right? Just keeping it going. I find a song that I like, and we're gonna keep it going. Okay, cool. So let's review some of these learning goals here. So that first lecture, right? We talked about the Rutherford model of the atom and all of the scientists that contributed to that. Don't worry about knowing dates or names or where the people are from, but you should understand the structure of this atom and its basic components. Okay, we talked about isotopes and how to distinguish them using mass number, atomic number, and atomic symbols. Remember, atomic number, number of protons, mass number, number of protons and neutrons. I didn't say in the previous lecture, but I do not expect you to memorize the periodic table. I think that's kind of an old school thing that people used to do to torture chemistry students. You do not have to memorize the elements on the periodic table. But you should know, here, look, this is going to come in this lecture. Be familiar with the periodic table and its various regions. So I do expect you to know the various regions of the table, but not memorize all the elements and the symbols. The more you do chemistry, the more you'll know those things. Okay. So understand the difference between exact mass and average mass. I think we talked about that pretty well. So exact mass is it's the exact mass of each of those individual flavors. But remember, if I go and scoop up a collection of atoms, I'm going to have a random sample of isotopes based on the natural abundance, right? I shouldn't say it's random. It'll seem random to us. But if I go and scoop up a sample of carbon anywhere in the universe, roughly 99% of it is going to be carbon-12, okay? So those natural abundances are, for the most part, universal, okay? So calculate average or exact mass as well as percent abundance. So I just showed you how to calculate the average mass, okay? But consider that's an algebraic equation, right? So if you knew what the average mass of something was, you could also calculate the exact mass. And so just to review, right, this calculation we did on that previous slide, right? The average mass, so I'll add to that. So the average mass is always going to equal, the percent abundance times the exact mass, okay, plus the percent abundance times the exact mass. And so here I just showed you like if there's 2 isotopes, but if there was like 4 isotopes or 7 isotopes, we would just keep doing this for all the isotopes and all their natural abundances, okay? So if I knew what the average mass was and I knew what the percentage, let's say, I could ask you to solve for the exact mass for only one of those ions, all right? So I think there's some example problems of that in your homework, okay? So now we're moving on to this next stuff here. Be familiar with the periodic table and its various regions. And so this is where we're going to focus on in these next lectures, okay? So I'm going to come back to this at the end, this nucleosynthesis 2.9. I'm not sure why I put this right here. Let's keep going with talking about the periodic table, okay? So it was actually Dmitry Mendeleev, who arranged the first version of the periodic table. Pretty amazing, because there was lots of holes and gaps, right? Like you can see there's some gaps right here, but was still able to determine where these like undiscovered elements should go based on periodic trends, okay? We're going to talk about periodic trends for the next year and how Mendeleev, amongst others, were able to discover these periodic trends, okay? So, but what I have now, I'm going to go, at the very end of these slides, I put in a generic looking periodic table here. And some of you are going to have really fancy looking periodic tables. Some of you are going to have really generic looking ones. I think it's important to be able to look at like one of the simplest periodic tables and still know what's going on, what all this stuff means, okay? And so I'm going to come back to this slide quite a bit, but the first one I want to point out, I know it's kind of small, but look, I'm going to circle this carbon, and look, it says 12.011. So in that previous lecture, we calculated the average mass to be 12.01. And obviously, if I had more significant digits, we could have gotten to that 12.011. So that's the first thing to take note of. All of these masses, look, nitrogen, 14.007. Hydrogen, 1.008. I realize they're hard to see. So find a periodic table, right? Find a super high resolution, fancy, interactive one. I don't care. Find one that you know how to use, okay? But understand what all the things are on it. So first thing now that we should understand, this number here with all the decimals, those are the average masses. So we don't see from this simple periodic table what the natural abundances are of the other flavors. But what we should take note of, look at this number right here. 1 for hydrogen, 2 for helium, 3, 4, 5, 6. That's the mass number, okay? And what's the mass number again? Oh, excuse me. I said that wrong. I said that wrong. All of you people on the internet are freaking out right now. The atomic number, excuse me. That is the atomic number, which gives us what? That's right, the number of protons, okay? And so you can see it just counts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? It's in order of the number of protons. So on this very simple periodic table, we don't see the different flavors. We don't see the number of neutrons. However, something I want you to be familiar with. Look, if I see that this mass number, atomic number is 6 protons, and I could see the average mass of this carbon is 12.011, call it 12, that tells me the most common flavor of carbon has to be carbon 12, because the mass is very close to the number 12, okay? Similarly, oxygen, look, 15.9999. That tells me the most common flavor of oxygen is likely to be oxygen 16. And so what I can do from there, so if it's approximately carbon 12 and there's 6 protons, that means the most common flavor of carbon is carbon 12 with 6 protons and 6 neutrons. Okay, same with oxygen. If we see here 8 protons on oxygen and its mass is roughly 16, 15.99, right? Then that tells me the most common flavor of oxygen is oxygen 16, 8 protons, 8 neutrons. And we'll go back to that sodium example that we did earlier. And I know these are small, so hopefully you can zoom in and find a periodic table that you like. Sodium 11, 11 protons. So we can see the mass is 22.99999 something. That means the most common flavor has to be sodium 23, 11 protons, 12 neutrons. Some of these are a little bit more difficult. Like, let's look at chlorine. Chlorine is 35.45. So the fact that that mass is like 0.45, that tells me it's hard to say if the most common flavor is 35 or is it 36, right? So when we see some of those masses that have decimals that aren't easily rounded to a whole number, that tells you there's quite a bit of a distribution of different flavors, and that's interesting, okay? So let's go back now. Okay, let's keep going. Okay, so now the various regions of the periodic table. So this was Mendeleev's, early periodic table. We know now we see it something like this, okay? So periods go across this way. Groups go down like that, okay? So I want you to know the name of these groups. That's part of the learning goals, knowing the various regions of the table. So group 1, this very first group, right, that would contain hydrogen. Well, hydrogen's not a part of it, right? But hydrogen's right there. But lithium, sodium, etc. Those are called the alkali metals, okay? Group 2, the next row over, okay? The alkaline earth metals. I should really say the next column over. Alkaline earth metals for group 2, okay? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Group 17 are the halogens. Okay, and hopefully you know group 18 are the noble gases. Okay, there's a lot more on this, but we're just putting it up, starting simple for now. Group 1, alkali metals. Group 2, alkaline earth metals. Group 17, halogens. Group 18, noble gases. Okay, here's a little bit more of that. Okay, so, right, group 1, group 2, 3, 4, 5, 6, etc. So now here's a little bit more information on this table, and here we can see the nonmetals, metals, and metalloids have been separated. So many of you know the very famous stair step, right, on the periodic table that separates the metals from the nonmetals and the metalloids. Okay. So you can see the nonmetals by far are outnumbered by the metals. There are far more metals in the universe than there are nonmetals. Okay. This interesting region right here, just these handful of metals, or really metalloids, right? We'll talk about these later on in the semester as when we talk about semiconductors and solids. Okay. And hydrogen, right? Hydrogen is kind of weird. You know, it looks like it should be a part of the alkali metals, but hydrogen stands on its own, right? It is really a non-metal. Okay. And then, of course, we should recognize this top group, the lanthanides, and this bottom group, this top period, the lanthanides, and this bottom period, the actinides. Okay. So, and you can see their properties, right? Metals, shiny, solid, conduct heat and electricity, malleable, ductile. So malleable means I can bend it. Ductile means that I can form it into different shapes and it still holds its structure. Solids, liquid, gases, okay, for nonmetals. The solids, the nonmetal solids are brittle. So don't confuse that, right? We can still have a solid that's a nonmetal. Think about, sorry, I just completely blanked out. Think about carbon, okay? Carbon is a nonmetal, but we can still have a solid form of that, all right? Okay, and then the metalloids, shiny like metals, but they're brittle like nonmetals, and they're what we call semiconductors. Okay? Let's keep moving on. So now another way of thinking about these atoms on the periodic table. So the main group, what we call the representative elements, so the things that you're more likely to come in contact with in your life, are group 1 and group 2, the alkaline earth metals, as well as this block right here that I'm going to later on in the semester call the P block. Okay. And now we know everything in here is, or not everything, but most of everything is the transition metals. Okay. And we'll get into why those are special.